Algebra 1, Day 70. Today we're going to be talking about utilizing square roots to solve quadratic equations. Now, square roots is something that you may not be familiar with. We haven't really covered it in our course much, but the simple thing to know is that there's always two answers to a square root. So, just as a brief introduction, I want to talk a little bit about square roots. First thing you need to know is they utilize this symbol, not this. Okay? It's got to have that little extra thingy in the front. The reason is that people typically reserve this for long division. All right? So, what exactly is this? Well, whenever we put something inside of it, let's say 81, I'm asking what are two numbers that when multiplied together, what is a number when multiplied by itself that will give me 81? So I need 2. That means 9 times 9. 9 is the square root of 81. However, isn't negative 9 times negative 9 also positive 81? It is. So that means that there's actually two solutions to every one. Now, as kind of preview of later math, you can also have cube roots, fourth roots, fifth roots. For example, the cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. Okay? But the most important part to remember is this. The fact that it has two answers. So this is going to be super important in what we're doing today. So let's go ahead and jump into it and let's get into those notes. So a second method for solving quadratic equations is taking the square root. In order to use this formula, your quadratic equation must not have a middle term, meaning no b. No b value. It's got to be equal to 0. So, the golden rule of square roots, which I don't usually call it that, but okay. Taking the square root of a negative will result in imaginary numbers. And for now, we call that no solutions. Okay? So, before we jump into that, I just want to show you something. So let us take a look at a graph. So I'm going to go ahead and graph a random equation. So as you can see, it has two solutions. 1, 2. And we've learned from transformations that if we modify these numbers, it's going to move up, down, side to side, flip it, make it skinny, make it fat, all kind of different things, right? So that orange one, let's see, graph function. All right. So the orange one we're going to say has two solutions. This guy has 1. It only touches right here at -4. So this guy in orange, two solutions. 1, 2, it touches twice. The one in red, 1 solution. It only touches the x-axis 1 time. Let's do another one. Notice the blue graph is way up there, and it does not touch the x-axis at all. It has no solutions. It's got imaginary solutions. That's what we're talking about. We're not going to be dealing with this. We only care about these guys, okay? So if you ever get a case where the factors are exactly the same, 1 solution. If you get 2 different factors, 2 solutions. Pretty simple. All right. So let's keep going. So of course there's usually steps to this and all kind of really cool stuff, but I want you to first just pay attention, okay? So the object of this is to get everything condensed down to where you can take the square root of both sides and figure out a solution. Now, 100% you can solve this by just graphing it, looking at the roots. You can solve this by factoring, and you can also solve this by square roots. Lots of different ways, okay? This is just another tool. This is not the end all be all. So just keep that in mind. If you don't quite understand this, you just need to be familiar with it and you head right back to what you understand, okay? So, first thing, what I'm going to do is I'm going to look at this and I'm going to say, all right, I see my x squared. There's no b value. So I'm going to go ahead and I'm going to move this 36 over. All right, so now I have x squared equals 36. So now that I have everything lined up like that, I can take the square root of both sides. The reason is one term, okay? So I'm going to go ahead and do that. Square root. Now over here with my x squared, that just cancels out and I'm left with just my x. Now I ask myself, what is a number when I multiply it by itself is equal to 36? 1, 2, 3. So I'm going to check each one. 1, 4, 9, 16, 25, 36. It's 6. So I write my 6. But because I took the square root, 2, there's going to be 2 possible solutions. Because positive 6 times positive 6 is equal to 36. But negative 6 times negative 6 is also equal to positive 36. So typically you'll see people write it like this. X is equal to plus or minus 6. And other folks might just end up writing it out like this. Lots of different ways to handle this, okay? So let's go ahead and continue on. Let's look at the steps. So first thing, we want to isolate that x squared, get them by itself. And we want to take that fancy square root of both sides. Remembering that my symbol has that extra little thing out there in the front. We're going to solve for x and include my plus or minus in the answer. This tells us that we have 2 solutions. One that's positive, one that is negative. Now, what happens if we run into a situation like these guys over here? Well, we're going to treat that x plus 3 as one term because it's squared. But that's also going to play a lot into how we solve this. But let's go ahead and take a look at this one first. All right, so first thing, I want to get this x squared by itself. Exciting move, great divide. I'm going to get rid of whatever is not touching it first. All right. Now I'm going to say, okay, can I take the square root? Well, no. My x squared still isn't by itself. So let me get rid of that 2 by dividing because it's multiplying. All right, so now I'm somewhere. Let me go ahead and take the square root of both sides. This guy cancels. And I'm going to ask myself, what is the square root of 144? I believe it is 12 plus or minus because it can be either one. There's my answer. Super simple. I could have also factored if I wanted to, and I would have gotten the same exact thing. And I'm going to prove that to you. So first thing, whenever I see this equation, I say, oh, they're both evenly divisible by 2. So I'll go ahead and take out that greatest common factor of 2. Now I'm going to multiply a times c, negative 144. I need 2 numbers that will add up to equal 0. I say, wait a minute, hold on. So negative 12, positive 12. There they are. Now I can split apart that b term. Okay, now I can factor out from just the first part. Whoops, hold on. Factor out from just the second part. And notice that the insides are exactly the same. Oh, whoops. Combine like terms. Okay. Split them apart. And I find out that guess what? Ended up right back in the same place. Same exact thing, just a different way of doing it. Remember what I told you, all of math spins back on itself. It's all the same thing. Don't ever let anybody confuse you. Okay? So let's go ahead and take a look at this cray-cray example. So for this one, for the purposes of this, we are just going to pretend like everything that's on the inside of this is a single term, okay? So I'm going to take my square root. Over here they cancel. I'm left with x plus 3 equals, and the square root of 16 is 4 plus or minus. Okay, now pay close attention to this math. Okay, I'm going to move my 3. I'm always going to write it in the front. The reason is so you don't confuse yourself. Now I have to break this apart because there are two separate equations here. X equals negative 3 plus 4, x equals negative 3 minus 4. If I solve them, x is equal to 1, x is equal to negative 7. Those are where my root, solutions, zeros, x-intercepts are located. All right, let us do the same exact thing here. So, first thing, I notice a coefficient in front of my 4. In front of my x minus 5. So I want to go ahead and get rid of that by dividing by 4. And I end up with this. Okay, now I want to go ahead and get rid of that exponent. So I'm going to take the square root of both sides. Remembering that it's going to have two possible answers. Now I'm going to go ahead and move this 5 over. And I'm going to split it apart. And I end up with my two solutions. X equals 14, x equals negative 4. Okay, so the very next problem is kind of a real cray-cray problem, okay? So don't trip, don't get freaked out, just pay attention. It's the same exact thing, it's just slightly more difficult numbers, okay? So let me go ahead, I'm going to pick a better color. All right. So a cliff diver dives off a cliff at 70 feet above water. So here's this little guy. Here is my water. And he's diving. And over here, 70 feet. This can be modeled by the function h equals negative 16t squared plus 70. How long is the diver in the air? Well, number 1, this is height. Number 2, this is time. X and Y, they're just naming it something different. They're asking me how long he's in the air. So he's going from 70 feet and going all the way down to the water at 0 feet. So it's some kind of intercept, right? This is when h equals 0. So I'll plug that in. Okay. Now they're asking me, how long will they be there? Well, I'm going to look at my t value, and that's what I want to get by itself. I need to find where that intercepts. So first thing I'm going to do is I'm going to move that 70 over. Well, this is weird. There's some negative numbers there, but that's okay. I'm going to keep going. I'm going to divide both sides by the coefficient. Okay, so that's the smallest that I can get it, which is fine. We'll go ahead and take the square root of both sides anyways. So when I take the square root, it gives me a really ugly number. So it's telling me that my answer is time equals 2.09165 seconds, either positive or negative. Now, this is where you kind of have to think a little bit outside of the box. Have you ever done anything that has taken a negative amount of time? No. That means that my proper answer is only the positive solution. So my answer is they're going to spend approximately 2.09 seconds heading down to the river or ocean. Okay. So I want you guys to go ahead and take a look at the practice problem, and I will see you next time. Have a good rest of your day.